Kelvin to Celsius and vice versa. Let's find out here. Oh, there we go. This is the formula here that we're going to use. So if you want to find Kelvin, you're going to take the degrees Celsius and you're going to add 273.15. If we rearrange this formula for degrees Celsius, okay, which is another option here, subtract 273.15, subtract 273.15. If you want to find degrees Celsius, you would take 273.15 minus the Kelvin, okay, or sorry, Kelvin minus 273.15. Kelvin minus 273.15. Okay, so those are your two formulas that'll give you vice versa, okay, kind of thing. Kelvin into Celsius, Celsius into Kelvin. Really, after a while, it's going to become second nature to you. You're just going to say, hey, I have Celsius. What do I do if I got 55 degrees Celsius? I'm going to add 273.15 every time. So if I give you Celsius, you add 273.15. So in this case here, I'm going to take, if I want to find the Kelvin, I take 55 degrees Celsius and add 273.15. When you do that, you're going to get 328.15 Kelvin, basically. Okay, so I guess I could put temperature here, temperature if you want, whatever. But basically, you just have to do that on the calculator. All right. So that, I guess that's what you just have to remember. If you give it Celsius, you add 273.15 to it. If it's a negative 55, just still on your calculators add 273.15 to that. You'll still get the right answer for that. All right. The only thing is this isn't going to happen very often. I'm going to tell you right now, but just so you know, just to do a little review here, right? If we're adding 55 and 273.15, what should my final answer be? How many significant digits should I have? Do I have the right answer up there according to the rules of addition and subtraction with significant digits? What are they again? Do you remember? Multiplying and dividing, you go based on the least number of significant digits, right? We've done a lot of that lately. Some of us need to fix that on our quiz a little bit, but other than that, okay. Adding, subtracting goes based on what? Remember? Decimal places. So fewest decimal places. This one's got one decimal place. This one's got two. So we really should only have one decimal place in our answer. So after I add this up, I probably should round it accordingly to one decimal place, 328.2 Kelvin. Okay? This would be my final answer for that. Remember the rock example, right? We had 48 kilograms. We had other ones that were 1 and 2 decimal places. The 48 kilograms didn't have any decimal places, so I didn't have any decimal places in my answer. Back to lesson 1. Same thing here. I have 1 decimal place, I have 2 decimal places. I can only have 1 decimal place when I'm done. Okay? This is not going to be an issue for you because we're going to take the temperature, we're going to put it in the formula, we're going to do some multiplying and dividing, and that's what we're going to base it on. All right? But for right now, sure. If I want to find degrees Celsius, so if I want to find the Celsius here, or the temperature in Celsius for that matter, I want to take 335.6 Kelvin and subtract 273.15. And that temperature will change it, that will convert it into Celsius for me. And I think it works out to be 62.45 degrees Celsius, or about 62.5 degrees Celsius. Okay? 62.5 degrees Celsius. Once again, based on the fact that we have 1 decimal place here, 0.6, we have 273.15, which is 2, but I can only record it to 1 decimal place because that's accurate. Okay, so 62.5. As far as your work today goes, or your quick questions that we're going to do, all of those have 2 decimal places, so literally, you're just going to type them in on your calculator and write down the answer. Okay, they match up nicely. Once again, you're probably not going to have to worry about this because all the questions we do from here on out are going to be in formula form, and we'll worry about that after. Go ahead and finish off those questions there real quick, the temperature conversion questions. talk about here with this here on the next page here. It's still in lesson 3 here. There is some standard states, we call them. There's a set of conditions agreed upon by kind of unanimously kind of thing. There are 2 commonly used ones. So there's one called STP, which stands for standard temperature and pressure. So in these questions that you're going to be getting tomorrow, quite often they're going to refer to this gas is at STP, which means it's at standard temperature, 273.15 Kelvin or 0 degrees Celsius, and standard pressure, 101.325. Or they might say standard ambient temperature, standard ambient pressure, which is 298.15 or 25 degrees Celsius and 100 kPa. These are on the back of your periodic table. Okay, so you don't have to memorize these or anything like that. They're constants, they're givens, and instead of writing these out, full numbers, they just sometimes refer to them as STP or SATP, all right? One of the things you have to be aware of in some of the questions, not very often, however, it is possible to talk about standard temperature. That's standard temperature. That's really its own thing, okay, standard temperature. And standard pressure, of course, would be this here. But they might refer to it as standard temperature, yet standard ambient pressure. So you could actually combine these 2 together in a formula. So if we're talking about pressure and volume and temperature and how they relate to each other, which is what we're going to do a little bit later tomorrow, we might have to use those 2 numbers together in that formula. Okay, so these are really 4 independent constants, I guess, if you want. Okay, so standard temperature is here. Standard pressure is this one here, standard pressure. And we might combine standard pressure with standard ambient temperature. So you might be able to combine those 2 together. So what I'm saying is, obviously, it doesn't always have to be this number and this number together. It might be this number and this number, or the 2 green ones here, or whatever. Okay, so just keep that in mind as you're doing these questions. If you see something that says standard temperature, well, that's 273.15. If it says standard ambient temperature, that's 298.15. Okay, and it'll say that in the question, of course. If they talk about standard ambient pressure, well, that's 100 kilopascals. If they talk about standard pressure, it's 101.325 kilopascals. Okay. All right. So just keep that in mind. Those are on the back of your periodic table. By the way, right here, it tells you that 0 degrees Celsius is the same as 273.15. If you add 10 degrees Celsius, it increases the Kelvin by 10 as well. So it'd be 283.15, right? Because you're adding 10 to it. If you had, for example, 25 degrees Celsius, it's 298.15. So it's just a straight across distribution, basically. There's no tricks to it or anything like that. As Celsius goes up, the Kelvin number goes up as well. Okay. That's it for that lesson there. So let's see here. Where am I recording?